So,
Yeah. Well, you can hit record right now. I guess anybody can hit record, right? Looks like.
I hit record.
You hit record. The other thing I was wondering is either one of you familiar with the domain-driven design type of thing? Because I'm wondering how hard a bridge between domain-driven design to Rholang would be.
I don't know what it is.
What you're referring to there, the domain?
Yeah, domain-driven design. Domain.
Domain what?
Let me put a link.
So I created a directory community. I went there, I did a git init. So this is a new repository that we're using for that. And then I'm copying the files from the prototype over, which include the to the new to the community directory. Okay, so we have these files here now, and I guess we can start with anything, but probably the locker we would start with first. Did you find what you're looking for, Ralph?
Yeah, I put a link in the chat. I was talking about domain-driven design.
Oh, yeah.
The idea is that you basically say, okay, here are the key concepts in the domain, and then I mean, it's probably more popular in the sense of getting like a database schema or something, I guess, initially from the domain, and then working off of that. But I mean, how complicated would the bridge between that and Rholang be? Is it?
Well, it's design. And it looks like it's, for handling complex problems.
Yeah, but I mean, I guess what I'm thinking of is like, what would be the right, for example, when I was talking about requirements, Greg mentioned bisimulation as a potential methodology. So I'm trying to see what is the closest thing between, or what would be a potential bridge between requirements, business requirements, or what is the formalism or representation of business requirements that brings us close to Rholang implementation. Sort of, you define the requirements and they can be converted into Rholang code, sort of.
Yeah, I mean, I certainly can't answer that. I don't know who's an expert in that. If we looked at
anyway, that's, I guess, something to noodle over later, but we can just focus on the depth that we're developing now, the voting.
So DDT kind of goes away from this complexity and incentivizes developers to make smaller libraries and work with those instead. So the more complex you you have to like make your code kind of encapsulated in smaller smart contracts, which can be seen as limitations. But in Rholang, you don't have it. It kind of, you can add as much complexity as you can, but it kind of, it becomes almost unmanageable. So I hope like in some future we're gonna see like some more tooling that can be like for unit tests and all this stuff.
Yeah,
I mean, I don't know if it's, I don't know if it falls in the same category.
Yeah. How is your visual Rholang coming along?
Yeah, it's not as much progress as I thought because of all the stuff. But yeah, it's gonna come eventually. Don't worry.
Sounds good. Okay, so Jim, you want to go back to the voting app?
We want to look over the liquid democracy. I mean, we have the prototype, and prototype was tested and it worked. And now we want to make it real. And so we had it running under robot. And we'll probably continue to have some kind of robot interface. I don't know, but we had problems with security with robot. So we might want to create a different interface that's not robot. We may use robot for some testing, but it's not clear that we can, I mean, we haven't figured out how to secure private keys yet with robot, unless everybody's running their own robot. So the contracts I copied over were the ballot and the community. That gives us a community of voters. So we can register people in the community, and then they can vote in that community. Is the way it would work. Was set up in the prototype. Okay, and the community used the directory utility contract. And the directory of the community tells us how to exchange properties. It points to the inboxes of community members, so we can send them capabilities. And then we have a locker, which is where people can keep their capabilities and privately, and not share them with other people. Okay, there's an internal capability. There was another thing we've been discussing today, which we'll postpone discussion on until we have Dan here. But there are schemes for keeping secrets between one vat and another vat. And then that would be what we're doing with the locker is we authenticate the user with a signed message, and they're the only ones that can access the capabilities that are put into the locker. They're the only ones that can find the locker, actually, or whatever. No, I guess others can find the locker, but they can't do anything unless they can sign the message, the proper signature. We will, let's say we, oops, it's not typing. Why isn't it typing? It died? Can you hear me? Looks like my internet's dead. You're all frozen. My internet went down again. This crazy thing. Um, so it says we're still recording. Um, so I log in as robot here, and then I go into community, and I'm looking at locker.row. And certain things have changed. You want to do things a little differently. We may want to let this work.
Were you going to share your screen, Jim? You're not sharing.
Sorry, I didn't hit the second button. So, I guess we'll just look at look how this worked before, and then we can see how we want to make it work now. We make a new name, locker, and that's the unfortunate name of the locker contract. And we have a trace and we have a standard out. Okay, that probably we want to change. Probably want to have some standard way of returning errors and stuff like that. But I guess we don't need to worry about that right now. And we have insert arbitrary because we need to be able, people have to be able to find the locker contract in order to make lockers. So we're going to have to insert that into the registry. And we have lookup here, which I'm not sure exactly what we're going to look up. We'll see. I guess we could look up. We don't use lookup. Oh, I spelled it wrong. We still don't use lookup.
Is it proof of stake?
What?
The contract, is it proof of stake? Because I see dead beef. No, I was making a joke.
Oh, I couldn't hear you too well. Okay, so for we're going to make a locker channel, and I guess the locker channel, I don't know what in the world we're going to do with the locker channel. Okay, the locker channel we're going to use. Okay, so I see what's happening here. We're using the we're writing the test program first. Okay, so we're writing to the locker, and I think this is a private key. Or is it a public key? Whatever. What we want to do is, what we're going to change this to is we're going to pass it a public key. A public key that owns the locker. And it's going to return the locker on the locker channel. And then it makes a new trinket, and it puts that in the locker. I guess this is the private key, which obviously we don't want to pass. We want to we want assigned value here. This is what I need your guys' help for. I haven't used those. I haven't used these functions to do the sign functions. Okay, and this creates a new trinket, and it puts the trinket in the locker. It updates the locker with a trinket. Then it gets the locker, and it finds the trinket, and it says got trinket. That's the test program. Any questions? Okay, so now we make a new URI channel, and we insert arbitrary the locker. We get back the URI, and then we do well, this doesn't define for the robot. It doesn't define $locker as the URI, and it does that because robot monitors the log, and when it sees define locker and a URI, it defines a macro. We could make this a named contract, maybe. Have to see. I've never done that. I don't know if you guys know how to do it. At first, I thought named contracts were only system contracts. I don't understand the restrictions. I mean, it seems like if anybody can take anything from the namespace, that may be a little bit wrong.
The name contract is what is listed on the top of the file.
The what?
I don't understand what is a name contract.
Insert sign. We're not using insert sign here. But if you do an insert sign, we could give it the name locker, and it would have the name locker, right?
Oh, okay.
I'm not sure what the restrictions are on doing an insert sign. That's something else we can find out. But in any case, we can define it, and we can get a URI and have some way of, having a table with the locker, the URI for locker being something, and then we can look it up. Okay, here's the actual locker contract, where we give it a public key. That's a byte array. And each locker has a self, which is the locker itself. It's just an arbitrary name that we're using to identify the locker. Then we're defining methods associated with self. Items channel is, I guess, where we store the items. Nonce channel is where we store the last nonce. And then it says making locker, trace. We're not really following the object capability model here because trace is kind of a global. We should probably pass a trace channel or whatever to be true to the object capability model. Okay, and then we're returning bungle plus self, which means we're returning a capability to a write-only capability to the locker. And when we write to self, it's going to be, we can get the nonce, we can update it. And is that all we can do? That's all we can do. Get nonce. So get nonce is going to read the nonce channel. Okay, so there's certain things that we can do right away, like we can change this to a peak, and we don't have to write it again. We're not changing it. We make that a peak, and then we don't need to do this.
Yep, I think you're right.
Okay. So then so where does he get this? What's this? Sig. Oh, the update method has a signature, which is byte array,
and the next nonce.
Right, it has a, you give it a nonce, so that because if if there's two requests that are the same, there's a problem. You can have a replay attack. So the nonce ensures, so if it sees the exact same transaction twice, it won't do it. Is that correct? I mean, that's how it's normally used. I assume it has the same use here. Is that Dan? And that's it. It's an integer. And then we have a map. I don't get this. It has more or more and dot 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 underscore. That's interesting. I've never done. I don't think I've ever done
Yeah, this is strange.
an and like this. But we're giving the name more. We're binding the name more to the rest of the arguments. Is that what we're doing? That would be, well, not exactly. Oh, because this is a map. We're binding the name more to a map. But we're not giving a name to the rest of the arguments. I'm confused. We're giving a name to the map. Okay, do you understand that?
No.
This is any map, right? This will match any map. The dot 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 is any number of key value pairs.
Okay.
Okay, and we're binding that to the name more. The way I would normally do this is I would say more, I would say first, comma, more dot dot dot, and then I would have two separate things. I would have the first and I'd have the rest. But this makes sense. He's binding the name more to the whole map. And then now he's doing it, he's using the object capability model correctly because he's passing the failed channel and an act channel. Which he writes errors to the failed channel. And writes, well, he writes nil to the act channel. You could write something like success.
This is a good way to do it because in my code, I don't do it this way. I just have one return channel, and if I return true, it means it's okay. And if I return a string, it means that it is an error message.
Yeah, I'm not sure this is good because I'm not sure how good this is. Because you don't, you're going to leave a reads hanging on these. In other words, if we don't write anything to the fail channel, and we later read the fail channel, we're going to leave it hanging all the time, right? It's going to be waiting for an input for a result forever. The more common technique I've seen lately is that we return succeed or fail in a tuple as the first thing in a tuple, and then when the actual return value is the next thing in the tuple.
Okay.
I think that's a better way to do it. So I think we should probably update that and make that a best practice. I think getting all these best practices down, I mean, we're all stumbling in the dark, which is the problem. And then gradually we come up with stuff that works. And that's what we need to communicate to other programmers.
Yeah, that's interesting to discuss about good practice.
I will start with using Visual Studio Code.
Oh yeah, I should be using Visual Studio, shouldn't I? That's interesting, yeah. And we give me the errors. Yeah, I should be learning to use Visual Studio. I should be stuck here in VI. I'm a bad boy. But I guess okay, and then we have this trace thing, which again is it's a global, which is not right. Not exactly clear how we should return that, how we should do these traces with an object capability, notion. I guess we would have to pass it. Trace channel. Okay, so then we read the nonce, and then we check to see if the nonce plus 1 is equal to the next nonce. And the next nonce is the argument that was given. Okay, and then it does a fail here. And the new way of doing that, we would return a tuple, first thing being a false, and then the error message, whatever. And then this writes back to the nonce channel. Nonce?
The nonce must be incrementally changed, I think.
That looks wrong, doesn't it? Wait.
But what I'm looking for is what the signature, it must be just the signature of the nonce, or do you have to sign a more complex object?
Well, that's interesting. I don't know how secure would be the signature.
I think.
I mean, here it's expecting a nonce plus 1.
Yes, That's very.
I guess it
That's
doesn't
very.
matter. Does it really? Does it matter what you sign? I guess I'm just worried that, you know, if you do, what happens when you do a signature in a very short message? It's still the same length of a signature, right?
I
But
don't
how
know.
does he check the signature here?
No.
He-
Yes,
He's
I
not really
think it's
the signature here. This is the toy keys.
no, this code is not complete.
What?
I think it's not complete, this code. Yes, there is.
It's secure. Ship it.
Yeah, it's not secure. It's you know, it's what Dan called the toy keys. Because we didn't have, you know, wrote this stuff originally when you know, when not very much worked in our node.
Mm.
I don't think he had
I
a lot
do
of-
signature. I do signature verifications in 3 or 4 projects on Rholang, so I know how to do it. But I don't use number for nonce. I use random strings, like 24 characters strings. But it's the same general paradigm. You have to provide a new nonce each time you execute a verified action. And
So
if the signature is successful, the nonce
But what about overflows?
overflows.
Yeah, I mean, if you're adding some +1 to a nonce, and you can eventually reach overflow if you're doing random numbers. So like it could happen.
In my case, I don't use numbers. I use just strings. And you do a string hex to byte. You got a byte array, and the signature must be verified against this byte array. So there is no overflow possibility because it's not incremental. It's just a new random string each time with the same length.
Okay. Okay. But in this case, like it's adding plus to a nonce, and it needs to be equal to the next nonce.
I don't understand
Yeah.
how it works at all. This is the old nonsense.
It might not even execute.
How does this? I don't get it. So, and the nonsense that I work with have always been sequential numbers. I haven't worked with any others. I'm not sure how we generate them if they're not sequential numbers.
You already in my repo. Oh, you are talking about random numbers? I don't know. But I can send to you the reference to.
Rholang. I guess we could pass the current nonce and the next dot in the call. But oh, he writes the old nonce back here. I see.
Yes.
This is in case when it failed. So again, we can take this.
No, you can't.
We
Oh yes, you can do it.
no, we may change it though, right? Yeah.
Yes, in the
We may
else
change it, so
you eventually
you have to read it. Okay.
And I had a question.
In case of an error, we rewrite the old nonce. And you know, this could be changed to a different noncing. I mean, I don't understand exactly why we've used nonces. I mean, what, in terms of transactions, money transactions and things, you just want to make sure that if you get the same transaction, if you get a replay of the transaction, it doesn't happen twice. So the nonce makes sure of that. It would, you can't do it more than once with the same nonce. That's the only thing it does.
Yes, and nonce is dangerous, but I think I know why it is a number in this case, because nonce might be dangerous if you only require a signature of a nonce. If the node is malicious, it can just it cannot propagate the transaction and read the signature inside the Rholang code, and then deploy another contract with a valid signature. This is why I think that nonce should not be done on numbers or strings, but on all the payload that is sent. In our case, I think it's the more value, because it is the value that we must update. So you should provide the signature for all these objects. This way, you are only able to update for this value and not another value, even if you have the signature. But I'm still using nonce in all the codes I have shipped. I'm still using yes, string nonce.
So
But
then,
number nonce is good too, because you know that yes, I think we should have to ask some.
okay, so more is the map that we were given, and we read the items channel, and then we write back to it the items with a union of what we're given here, the more. And that's it. That's all the locker does. Okay. So the only thing that needs to be fixed on that is security, the signatures, and the nonce, I guess. So if we look at the inbox, I guess we don't really have okay. The inbox is, I just guess, just one thing that's put in the locker. And I guess the client side code really is what it's what handles the and oh. Find. So we have a bunch of macros here that we define. They're written in Rholang, but they're really part of the client, I guess. I mean, it could be done. there could be utility functions on the chain. My locker update, my locker store, probably the same thing. My locker get, my locker, to make my locker, right? And we see that it creates a locker and it creates an inbox, a mailbox, and it puts the mailbox in the capabilities of the mailbox. There's the right to a mailbox, the receive from an inbox, which removes it from the inbox, and the peek in an inbox, which looks at something in the inbox but doesn't remove it. This is somewhat arbitrary. We can change how these work. The basic thing is we need to be able to make a locker and put an inbox in it when we add somebody to the community. And that's this channel. Where we make a new community, and then we can add users to the community and grant them the capability to update their entry in the community, which primarily the entry has to contain their inbox or their mailbox. So we communicate with them, and members of the community will get the ability to read the membership and in terms of admin capability, or is it make a new community, does return. It's going to return an admin capability, a read capability, a write capability, and a grant capability. And when somebody's added to the community, they're going to get a read capability sent to their mailbox. And we're sort of almost out of time. So what I wanted to do was get this thing committed to now I suppose I should have created this in GitHub first. So the question is, how do I, now that I created this already, is it too late to create it on GitHub? So what I do here is, I do a search on putting a repo on GitHub. Create a remote empty folder in the GitHub repository. Okay. So we want to go to the ArtChain community, right? And we want to do, oh, I just want to go to the ArtChain community here. We want to do a new, and we want to do, I'll call it community. Is that okay? Or should I call it our vote? Or I guess we do have a vote already, the repo.
You can call it vote 2.
Maybe I want to, I don't want to put it in here. Our vote 2020 is for the voting for October 2020. We have an ARPA, another one. Interesting. I don't think we have anything comparable to the community, so I'll go ahead and add it. Should I capitalize it? No.
What are you going to use this for? Because I mean, the name is already there in the community. This is more for generic voting by members. Is that what you're going to use this for?
It's for exchanging capabilities, and I guess it's for voting too. I figure, it's everything you need. I mean, it's the basic stuff you need to have a community, which includes the liquid democracy and the, directory of members and their inboxes. So you can chat with them or you can do anything with them.
So there's more like community management or something.
Yeah. Community management, capability, sharing, mailbox, chat, voting.
Liquid democracy.
Yeah. Okay, I mean, it's all part of, anything that's part of managing community capabilities. And I'm putting the mailbox and stuff in there is because, well, a lot of people in ArtChain, for example, don't want to have their email address public. Right? It may be that people broadcast their mailbox outside the community, but it's created, I guess, in a community, even if there's only one person in the zone community, whatever. Okay, so it's a public. Anyway, the default is private. Skip this step if you're importing an existing repository. Well, the existing repository, I don't have a README, but I'll do that. Follow the instructions here and hopefully set up. If you've done this kind of thing before, okay, or create a new repository on the command line. This is what I did. So I can just do this stuff. I can just do all this stuff. Just do the whole thing. What? What did I do? I didn't do anything? I don't know what did. Okay. So it created a README file, which is pretty much empty. It just has the word community in it. We could add more to it. And then it does an init. I already did that. I already did get init.
Yeah, it's saying it reinitialized.
Reinitializing existing repository. Okay, so that's no problem. Git add readme.md, git commit-m first commit. Okay, well, we have a little bit of a problem here. I'm going to control C out of this. If I do a git status, it's assuming we have nothing in it. But we have all these things that haven't been added. So I have to do a git add. Git add dash add. No. Oh, maybe it's capital A. Yeah. Now I do git status. And I see it's all green now, where it was red before. Use the git add file to include these. And dash capital A just added all of them at once. Then I do a git push origin master.
No, you must commit.
Oh yeah, I must commit. Sorry. Now that I added them, I have to commit again.
Okay, fine.
And now I do a push. And hopefully I can sign in.
Yeah, I do it exactly just like you, so it should work. And I have to set up SSH instead of password, but I have not done it.
Okay. So now look at this. We got this here. Okay then. So so who wants to add for the next? We can either do it or you can do it and then show us the next time.
You were echoing. Could you repeat it?
Who's echoing? Is that me? That's Raphael, I think. Um, so, Raphael, you want to take a crack at the signatures?
Yes, I can explain rapidly. Do you want me to explain my system with signatures and nonce?
Well, yeah, I mean, I guess you have shown us a little bit already. Now, I was going to say for the next time, I think well, I'm going to be taking off now. But if you want to go ahead and make those updates and commit it to the repository,
I think,
and just show us, that's fine. If you want to do it live coding in our next meeting, we can do that also. It's your choice.
okay, fine. The locker.row, yes, I think I can update it so it works with nonce.
Okay, so now, are you a contributor in our chain community?
Yeah, I think I am, but if I'm not, that's fine. I'll just, I will show it next time, and then we will push it
You
together.
make a pull request.
Yes.
All right, guys. We're at an hour and a half now, so I'm going to take off. If you guys want to do something, go ahead. Is there anything anybody wants from me before I leave? Thanks, guys.
Yo,
Go ahead.
Yo, are we okay with the system? So basically, the output from the discussion we had is that I think we can use logs already, but I don't think it's the best system. So I will try to understand the trace API and to have some subscription and trigger events from what happens in Rholang. So I will try to understand how trace work.
And that's going to require an extension also, right?
Yeah, and eventually it will become an extension. But now I will build a separate Node.js program.
Right. All right. Sounds like a plan. So the next meeting is Tuesday afternoon at this time. It's possible that we'll do other things at that time.
Tuesday or Thursday? Today's Thursday.
Right. Yeah, I mean, our next DApp developer meet, hour is Tuesday at this time. Which
Okay.
we can work on this or something else. And actually, I was thinking that it's probably a higher priority for us to do the voting for the that I put in here. What is it? Put in here a link to the anonymous purely democratic voting for co-op members in October. Now that's actually probably something we can sink our teeth into a little bit easier even. It has to be written from scratch. We have a repository for that. I mean, we have another repository for that, I believe. So we can work on either one. And actually, what I was thinking of doing today was going through the spreadsheet And I don't know where I have that open. Must be this one. That's really Excel, huh? So this is, so we have to copy this. We have to look at the instructions. Copy this, and then we have to put it in here. Okay, so if this wins a prize, Liquid Democracy plus Check Trust Metric, it's really both projects. We have the this document. We have to develop election app contract. And essentially, we're going to generate some random tickets, and that basically has to be done offline because those random tickets are capabilities. And we don't have any way yet of sending private capabilities off out of our, maybe someday we will. But for now, we generate the random tickets offline. Okay, we hash them, and we use the hashes to store the results of the voting. And so when somebody runs the election app, they're going to give it a ticket. Ticket's going to be hashed, and their votes are going to be stored under that hash, right? So we can really work on that on Tuesday, or we can work on the signatures for the other one.
So how does this voting app relate to RV 2020?
This is RV 2020.
Oh, okay.
This is the voting for RV 2020. Okay, if we're going to switch to something like Liquid Democracy, we're going to have to take a vote. We're going to have to vote to do that. I think that should be one of the orders of business. Is to use the other difference is that the Liquid Democracy is not anonymous. Okay, if we're going to make it anonymous, it's going to be a lot harder. We probably need something like the zero knowledge snarks or whatever. In any case, in order to use it, we basically need to have an anonymous vote to use this. In the meantime, this Liquid Democracy is only for getting sentiment of the members and making better decisions.
It has to be anonymous as well.
It's not going to be anonymous on a public blockchain. In other words, well, for decision making, you don't want anonymous voting. I mean, for the decision process. For making the final decision, you want anonymous. But when the sentiment is changing wildly from day to day, you want people to explain their positions. You don't want them to be anonymous. You're not going to make good decisions that way. Then the final vote, you don't want peer pressure on people to vote one way or another, so that you want that to be anonymous. But by the time you go to a final vote, pretty much should have made your decision already. There's, decision best practices. If you say no and I say yes, it should put us together into a discussion. See if we can reach consensus peer to peer. That's the way good decisions are made. If you have the two poles at the top, the Democrats and the Republicans, you're going to have a fucked up country. Or you'll have a government that's not so cool. I don't know. It's now let me know what you want to do on Tuesday, and we'll do it.
It's too bad we.
On the 2020. And we can do our RB 2020, can have both. We can do the pure democracy first, and then we can look at adding, that's another approach, add liquid representation to it. But if it's all anonymous, I don't know what anybody else's ticket is. It's not on the blockchain. So if I delegate to you, how could that be possible? I don't know.
You know those links that I sent you with functional encryption? Like maybe somehow we can utilize that for the final vote from the delegates. Because with this method, you can actually count votes and not actually revealing them.
Didn't that use zero?
All you get in the end is the actual result of the voting.
Didn't that use zero knowledge, Bruce?
No, it uses circuits somehow. So basically, it encrypts the actual method. So right now, you can only do like cross product. It was.
Look at it again. When I looked at it, I didn't think we could do it on our chain. Not currently, but I could.
Actually, integer do metrics. We'll see. I will just read here. This example demonstrates how multi-input function encryption scheme can be used. Here we assume that there is a number of clients encryptors, which each with their own corresponding input vector. So that input vector could be like the voting for each participant. Like 0, 0, 0, 1, 0, 0, 0, something like this maybe. For each, and each entry can represent like yes or no. A trusted entity generates all the master keys needed for encryption and distributes appropriate keys to appropriate encryptor. So this could be like the centralized entity co-op that kind of gives those people those keys. The actual delegates, basically. Then the encryptor E uses their keys to encrypt their data. So the delegate makes the vote and encrypts it. So the decryptor collects ciphers from all the encryptors. So that's basically the encrypted vote. So the delegate does not have to reveal his vote to the co-op. You get it? That's kind of the point. It then relies on the trusted entity to derive a decryption key based on its own set of vectors. And that could, yeah, we will come to that. With derived keys, the decryptor is able to compute the result, inner product over all vectors. So, we can figure out how we could use it maybe. So we have like one vector, right? And we do a dot, another one. Just gonna give a small example.
What am I missing here?
It's gonna be A times 1 plus B times 2 plus C times 2, etc. And that gives like an integer. So how can we utilize this? Because we can actually hide one set of vectors from the party that's gonna be doing all the computation. So this vector, for example, this vector might not be seen by the co-op who's counting the votes. But eventually you're gonna get the result.
But how do you prove the result? I mean, you have to reveal the vector.
You don't have to reveal the vector.
Then how do you prove the vote? I mean, if you have the vector offline, somebody can make up whatever vector they want and get whatever result they want.
Yeah, but we can make that the vector looks something like, you know, 0. Like you have like one vote in there. And if we dot it with identity vector, like just has ones. So what you should get when running this is 1, right? Because 1 times 0 is 0, plus 1 times 0 is 0. Then 1 times 1 is 1. So what this means is that in this array, you have actually one vote, like one integer or one number that is not 0. And there must be 1 because the result has to return 1. So the counting entity can actually make sure that the voting form is valid for it to continue counting votes. By the way, could you somehow mute me, or I don't know, because I cannot actually speak when I hear myself. You know how it is, like when it's delayed.
Can you turn down your volume?
Can I? But you won't be able to hear me.
Turn down your speaker volume.
How do I do that?
You have a little speaker in your taskbar.
My speaker, but what does my speaker have to do with anything? I'm wearing headset.
Your microphone's picking up your speaker. Oh, Raphael's.
Someone does.
Yeah.
Okay, it's Raphael. Makes sense.
What did I do?
No, I couldn't speak properly because I could hear myself speaking, and you know when you talk and hear yourself in echo, it kind of messes with your head.
Yeah, it was listening to you was a little bit of a challenge with the echo. So
Yeah.
I didn't realize. I mean, you can usually tell who's echoing because Zoom will put a green box around them. But when I guess when I looked, I wasn't seeing the green box around him because it was a green box around you when you were talking. Hold on. Well, I'm not convinced, but I will.
And then basically what we have is like a set of encrypted vectors for each
The point
member.
the point is that if that's all kept offline, I don't see how you can have the votes online and prove them online.
You know, you can prove it. You can prove them mathematically. I mean, you can just put the votes on the chain, and you know they're gonna be there forever, like a public record. But you will always be able to read the final result. That's
What's
kind
the
of
secret? I mean, what's the secret? There has to be. I mean, how's the secret handled? I mean, if there's no secret, then obviously it's not it's not anonymous.
It is anonymous. I mean, those votes cannot be read by anyone except for the one who's making the vote. But you're able to do the computation on those numbers. I mean, you can just put an array, like, and put anything in there, and encrypt it, and then send it to someone who can actually do some computation with this array and get the final result without actually seeing what's inside there. Yeah, I know it kind of works like magic, but that's kind of what's so special about it.
It's very strange because I can't understand, because from what I understand, we need a third party who can look at all the votes.
Yeah, this third party is the entity that's generating the keys for the delegates to vote for. So those keys encrypt the data, the votes. And then when those results come in to the trusted entity, this trusted entity then computes all of those votes together to get the final result without seeing who voted for what.
So if I'm going to submit my votes,
Yeah. Anyway, when we have something like this, at least like for each ticket, if tickets could look something like this with a set of like zeros and only one toggle the integer, like a boolean, a one basically.
We would have a vector of 900 entity, and we would have we would need infinite precision integer math, right? Do we have infinite precision integer math on our chain?
I don't know how, I mean, we can't actually do this on the chain. It's not possible unless we kind of integrate this library into our node itself, which is not going to happen, trust me, because it's C++ library. It's kind of, I wouldn't call it experimental, but it's not something you should like try to use in production anyway. But it's functional enough to use.
Well, I'm most interested in what we can do on chain, and
but it will be hard to do it anonymously.
I think we for for the decision-making process, I think we don't want anonymous voting. Final votes, yes. Decision-making process, no. No, we have to put together people who agree and people who don't agree.
Yeah, but that's kind of the question. Do we have to have like anonymous voting?
Well, yeah, I mean, I think we do, unless we vote to use something else. I think
Do members have to be anonymous or the delegates?
The voters and the delegates have to be anonymous. I mean, you can't publish who is for an anonymous vote, you want everything to be anonymous. And basically that means you want it off chain.
Mm-hmm.
You know, the way that the current plan is to handle that is to put the tickets. And
yeah, man, this could be like the way to generate tickets. You create like a key for the trusted entity, generates a master key. And then from there, you can derive keys for all the members who vote. You can make like as many as you want and send them.
Which requires infinite precision arithmetic. We're going to have 900, we're going to have a vector of 1,000 long, right?
No, not really. I mean, are you talking about
members? If we have 1,000 members, it's going to be a vector of 1,000. Or if we have 1 million members, it's going to be a vector of 1 million.
I mean, I already ran like a test with arithmetic, with doing calculation on arrays of like 10,000, and it kind of takes a little while, like maybe 20, 30 seconds, but it's not like jailbreaking.
You overflow when you do multiplication?
What?
Doesn't it overflow with multiplication?
No, I mean, it shouldn't. Especially if we use like those bits rather than any integer. So each slot kind of represents the option for the vote. It could be like this. What could be the example of a vote?
Now, if you had 5 voters, isn't the top line what you would have? You'd have to have 5 different numbers there.
Yeah, I mean, like, what could the voting topic be? Like A or B, or like A, B, or C, or which option people can choose in a ticket?
Well, we would have selection. We could have plain text. We could have ranked questions. But to look back at the requirements, I don't know.
Yeah, I don't remember those.
I don't know that any are in stone, carved in stone. But we have runs on our chain, anonymous voting, employees' email address, our chain, co-op identities. Okay, so there would have to be some kind of process where we would get a public key for the members. Yes, no.
This is why I thought about just sending them the encryption key so that they can encrypt their votes. They don't have to generate anything. And I mean, yeah, if you send them the encryption key, basically whoever receives it can vote. It's almost like object capability, I don't know, in a way.
How would you know who voted? I don't understand.
I mean, you just send it to the person, this encryption key, and
And they can send it to anybody else, and whoever they send it to can vote?
In a way, yeah. I mean, because
Each person would have a unique encryption code, right?
yeah, they are unique. Yeah.
And I mean, that's basically what ticket is, unique key. But it's not. Um, uh, how would you count their vote if it was encrypted?
This library does it. So all you need to do is to send them the encryption key so that they can encrypt their votes in. And when you receive the encrypted data, you can do computation on it. You can check if the vote is valid if it only has like one number set, one option.
Yeah.
Or two or whatever. Like we could figure out how to make it. But I think this method could work for anonymous voting. I don't know how to do it in Rholang, unfortunately, and on our chain.
Well, I mean, this would basically work. I mean, we would have to send the key on a different channel, right? We'd have to generate keys on a different channel. I'm trying to figure out how we would decrypt it, though. If we just give them a ticket, we don't have to know who they are.
Yeah, you just send them the encryption.
We give them a random ticket. We don't have to know who they are.
It's not bad. So this is a co-op. What they do, they generate like a key, right? It's gonna look like this. There's gonna be a master.
What do you mean, master key?
That's the one you can generate other keys that people can encrypt with. So you need this key to actually be able to read the result of the vote. So what happens is that you can generate like a ton of functional keys. Yes.
So I was just going to record the responses with the hash of the key.
What?
The plan that I had here was we would just generate the random keys, and we wouldn't need to have a master key. And we would
yeah, but you still need master key in order to read the result of those member votes. And then when results come in, you can actually just publish the master key publicly, so everyone can read the.
Now, if the election is transparent, you can't encrypt it. You can't encrypt. Okay, you're saying. Okay, so you're saying they could submit their own results. I have to see how that could work. I mean, here we were saying we were going to have a election app where you would give it your key, it would hash it and store the results based on that hash. The only thing is it would have to know which hashes are valid tickets. So you would just have a list of the valid key hashes.
I did not follow. Can you repeat it?
Okay, you would generate 1,000 random keys. Okay, and then you would hash them, so you would have a list of 1,000 hashes of 1,000 random keys, which would be stored on the blockchain. The hashes.
Okay. Yeah.
And now we have an election app where you give it the key and you give it your votes. Okay, it hashes the key and stores the votes under that key, under that hash. and it tallies the votes, and everybody can validate that their vote hasn't been tampered with, because they know the key that they used. They know the hash of that key. They can look up the hash and make sure it corresponds to how they voted. So you can prove that the vote is correct.
Yeah, so basically they can encrypt their own votes. So these are going to be the votes. So what you essentially get is like nonsense. Like ton of it's basically unreadable. So
well, they get actually submitted under their own ID rather than having an election app that submitted it.
I know, basically, like the user who has this voting key, right? He hashes it and gets like a signature of a slot, like where he should submit the result, right, on the blockchain. So what he sends is
the election app submits the hash and the votes without any encryption. You want to be able to know what the votes were for that hash.
Yeah, but anyone can calculate the votes. Anyone will be able to calculate the final result if master key gets published.
You're talking about what, my scheme now or this scheme?
No, I'm talking about the schemes that I'm trying to demonstrate. I don't know how.
Okay, so how does it use a hash?
It just uses a hash for like a item slot where individuals, members can put their result, like encrypted votes in on a blockchain. So it's kind of being public basically. So it's like a permanent record, so that anyone can just take those encrypted votes, and once the master key gets published, anyone can just check the results of those votes.
The master gets published.
Yeah, I mean, that's when you know the voting has closed. So the master key gets published and everyone can just see what the votes are.
So the master key can decode any of the votes, even though they're encoded with separate keys. Okay.
I mean, it cannot decode individual votes. It can only process them and do computation on that data. It cannot see what's inside, and no one can see. So even if the co-op like creates a master key, they send they derive a member key, right? A member makes a vote, encrypts, and puts it on a blockchain. Co-op cannot read what the member has voted. No one can, no one will. But what eventually, like, you can, if you have like the master keys, it's gonna be public anyway. You can double check the results just by doing it offline completely. Like just taking all of the encrypted tickets and kind of do a computation, and here we go. It's kind of like a proof of.
It's like a zero knowledge proof, right?
Yeah, without revealing as actual keys, member keys. I mean.
So you would know who did each vote encrypted.
Yeah, you don't know what's inside that vote. They could have been, like I said, like I showed in those examples. You see, this person vote for option 1. This person also vote for option 1. This person votes for option 4. But only those people know like their actual vote, no one else.
So this, where'd it go? I don't know why my, where is the voting? I see the functional encryption library. Does this actually talk? What's the URL again of that where it describes the voting?
Which voting?
The CIFER. Voting.
I mean, there is actual example of voting. It's just does a cross product on 2 different vectors, but we can utilize it for voting, like in this example that I showed here. I mean, we just need to stick to basic types of like 0 and 1.
Well, we have at least 3. We have yes, no, and abstain. So we have at least
that. Yeah, that kind of makes it even more. But yeah, we can make abstain if there is nothing set in the ticket. Like if someone sends all zeros, like 0, 0, 0, 0, 0, then it's like
they may abstain on one question. They don't abstain. They're not abstaining on all the questions.
Yeah, I was thinking that this is per question, more like this. So you have a question and like yes or no or I'm not sure. This is the example that I know how to do at least. So if you check the cross product of this and all ones, basically you get 0. But so it should be less or equal 1. Or basically in the range of 0 or 1. This is how you can get like yes or no or I'm not sure type of questions anonymously.
I'll have to look at it a little bit. I mean, if you know, it sounds like almost if we start running it this year, it'll give us the results next year. But I don't know.
Yeah, you mean it can be a slow computation?
Yeah.
Not with a couple of thousand members. It's not really that much. Especially if we're not dealing with large integers. It's like 0 and 1. So I wouldn't be too worried about it.
Yeah. So so that's an option. Okay, so we have method 1.
For anonymous voting.
Yeah, this is all. This is DAP 20 and 21. This is anonymous. Okay, method 1. Okay, I'm not even considering delegating at this time. I mean, it seems to me it's going to be complicated enough without delegating, and if we can figure out how to do it without delegating, then we can try to add to it delegating. Well, that could be method 2, right? Is what you're suggesting, a different method, and that's that different method is
It could be like a two-round voting system where first people vote for the delegate, and then those delegate actually makes the vote. If you like,
with liquid democracy, I can choose anybody. I can delegate to anyone or no one, or to myself, right? So I guess that's sort of around. I mean, in other words, we have decisions every day. Okay, and if I have a delegate on technical stuff and a delegate on the business stuff and a delegate on community stuff, okay, they always get my vote unless I vote every day. Okay, but I guess so. There's two different problems. There's the sort of the continuous decision making, and then there's like the special votes, whatever. So method 2. Okay. And we need to, understand the steps here of how this is done. No, I mean, the method 1, I think is very doable. I think it's something we can complete. Method 2, I'm not sure about it at all.
I mean, we can experiment still until October.
Yeah. Now, it would be good if we had enough people so we could try both, have a couple of people work on one and a couple of people work on the other.
Yeah, good thing that at least I tried this library. I know it works. I even integrated it into Godot engine for the fun.
What?
I was thinking like in terms of making a game where you're supposed to hide your solution somehow, but you still need to be able to validate that the player kind of found the correct puzzle solution without player having to reveal the solution itself. So that's kind of where this research came from.
Definitely, I mean, it seems so much like the zero knowledge. I guess it's different. It's close to zero knowledge.
Not really. I mean, it uses circuits. I'm not sure if it uses zero. I mean, zero knowledge is all about like sending the proof that you know the secret, right? So over the internet. So if I like have two balls of different color, I just like put them behind my back and like kind of switch them or not, and then I can show them to you. If I'm colorblind and that person is not, so that person can like tell me if I did the switch or not, and then I repeat it. So I will not like know the actual secret, but the person like.
Right.
It's kind of the easiest way for me to explain to other people what zero knowledge proof is.
Okay.
But I could.
I guess what do they call it? Hyperphonic encryption, hyper something or other encryption. I guess I'm confusing that with zero knowledge, where you can do computations on the data without it being revealed.
Yeah, it's the same concept. It's close to zero knowledge.
All right, I gotta go.
It has nothing to do with zero knowledge as far as I know.
Okay, see you guys later.
Okay, bye.
Thanks for everything.